Hi guys, we're going to be going over engineering design. This is standard 8.ETS1.1, and this is going to be a relatively short review, and I'm really going to just refer you back to 8.PS2.1 as another standard that goes along with this. Also, we went over the PowerPoint about magnetism, and it also talked about generators and motors. And so pretty much I'm just going to refer you to that one. But on this one, it specifically states that you could develop a model to generate data for ongoing testing and modification of an electromagnet, a generator, and a motor such that an optimal design can be achieved. And if you think about engineers, they're always working to make things better. Through time, everything seems to get improved. You've noticed this with your technology, how the cell phones have become better and better, and that doesn't happen by accident. That happens through a lot of testing that the engineers will do, and you may actually select a career like that. But they're always trying to make things better, and to do that, they're always going to be looking for things that are not optimal or the best. And so they're always going to be looking to make it just a little bit better. Can I make this a cell phone a little bit smaller or a little bit bigger or a little more clear as far as the camera is concerned? And if you'll think back to the electromagnet that we made in class as just the most simple and basic of the little projects, remember we had the iron nail, we had the wire core, and then we had a battery. And what you could do to generate your data on this particular type of an experiment, you would just create a chart. And the chart, you're going to, you could label the size of the battery that you have. You might have a chart that is about the different materials you're using for your iron core, and then for the number of loops in your wire, or maybe the size of the wire. Does that matter? And remember, when you're talking about the scientific method, how many things can actually, or how many things should be changed by the experimenter during a scientific investigation? And the answer is one. There should be one thing called the independent variable. And I believe Ms. Peak has done a video on independent variables and dependent variables. But there should be one thing that the experimenter changes in order to have a very, very good experiment. And this is in the scientific method. And so and that's the same thing in engineering. I would recommend just getting the basic electromagnet created. And then I would change first the power source, the battery, for example. And you could leave, the same core. You could leave the same number of loops and just change the battery and then record your data. So you're going to have developed a model for this electromagnet. Then you can uh, create your data into a table. On one side, you could put, say, for instance, a AAA battery using the same iron core, the same wire that you have, uh, the same amount of coils that you have done, and then the same thing you're trying to pick up. It may be paper clips. That seems to be the most standard thing that people use. And so you could use the AAA batteries and simply see how many paper clips it picks up. You could then move to a AA battery and just keep working your way right up like that until you have developed a chart. You have generated data that goes along with that particular electromagnet. Then the next independent variable you could do, you might change the type of material you're using or the size of the iron core and use that as your independent variable. But I believe you need to make a new table that shows you testing the different cores that you end up using. Create a new table. Do the same thing with the number of coils that you do. In that situation, I would recommend using the same battery, for each one. Remember, you only want to change one thing in a scientific experiment, and that's going to just help you get really, really clear results. And then you can look at your different charts, look over all the different um, results that you have, and then you're going to come up with a hypothesis, a best educated guess on what's going to make the best or most efficient electromagnet for you. In the same way that you do it with electromagnets, the next thing would be uh, you could do the same thing with a motor. And remember, we had talked about the homopolar motor. I believe you could watch a little video on that. It's an easy Google search. You can just pull that up, or different motors. Look at those and see, and remember, a motor is going to take electrical energy and turn it into mechanical energy. In other words, energy of movement. And so, once again, when you're creating an investigation, you want to change one thing. That one thing is independent. It's the independent variable. And the same way we did it for basic illustrative purposes with the electromagnet, you could do the same thing with a motor or a generator. If you can create a generator, just for an example, you may have some fins that the wind, you might set a fan to blow those fins to see if it will use that mechanical energy to create an electric current and light up a light bulb. And I'll show you an image of kind of what I'm talking about on that. Okay, this is just a simple image, and you can actually uh, go to a Google search and come up with different things. But this is an example of a little generator. And notice you need to have a little DC motor like we had at school. A lot of y'all use those. But basically, you were going to turn this, in this situation, they're using little bottle caps, to spin. And so you could, the same way you could just create a chart. How many bottle caps did you have? The size of it. Remember, change one thing, that would be your independent variable. And then see how bright the light gets. Does it light up very well? Brightness. And you can do different kind of testing that way. And basically, this whole standard is about being able to generate data and creating models. You can do this with motors, like we talked about, the electromagnet and the generator. And so I want you to be confident and go out there and experiment. Hopefully this has been enlightening to you. Hopefully it just refreshes your memory to some degree and maybe stirs your imagination. And I would encourage you to go out and to explore the world around you, and to never stop learning. Anyway, stay safe, and I will see you on the next video.